Tonight's lesson is going to be on section 1.6, which is about compound inequalities. So last night we looked at inequalities that were simple in that it was just one inequality statement. It wasn't two inequality statements in one problem. So we would have problems such as graphing this inequality here on the left or graphing this one here on the right, and then that was it. However, in tonight's lesson, we're going to be graphing both on the same number line rather than two different ones. So the first thing we're going to do is we're going to try and describe a solution set for these inequalities that we have. So the first solution set we're going to look at is the one on the left, okay, and this is all numbers greater than negative 8/3. That's what it says here. We are going to the right. Negative 8/3 is our first number. It's not equal to, so this is going to be all numbers, so we'll write this in words, all numbers greater than 8/3. So then to write that in mathematical terms, I would do x greater than 8/3. And we also want to look at the second one, which is all numbers less than 7/4. And the reason why it's less than is because the arrow is going to the left, and we start at 7/4, but we're not equal to there. So this is all numbers less than 7/4. So when I write that in mathematical symbols, that would be x less than 7/4. So the inequalities I'm looking at combining into one graph is x greater than 8/3 and x less than 7/4. So what I'll do is I will graph both. So I have negative 8/3 and 7/4. There's a 0 in between. I know that it says that it's all numbers greater than negative 8/3, so that's going to be opening on negative 8/3 and then going to the right. And then it's all numbers less than 7/4, so open on 7/4, going to the left. And then what's being different is that here we have the word and. So that means we want everything that's a solution for the inequality on the left and on the right. So it has to be an answer for both. So if you look at our graph, we actually have a small overlap right here. So if we were to graph this on a single number line together, again, we're going to put negative 8/3, 0, and 7/4, and then it's everything that is an answer for the both inequalities. So it's going to be from negative 8/3 all the way to 7/4. Okay, and so that is a compound inequality. So to be more precise, the graph above shows the solutions of two inequalities. The two inequalities form a compound inequality, and a compound inequality is made up of two or more inequalities. So for our case, we're going to be strictly looking at two inequalities. So to start off, let's just start by trying to describe a solution set from a compound inequality. So in the first example, we've got a number line with negative 3, 0, and 2. And we've got an open circle at negative 3, and then everything less than negative 3. We've got an open circle at 2, and then everything greater than 2. So this is what's called an OR inequality. Okay, so that means that instead of having an overlap like we did in the previous example, they will be moving in opposite directions. So that means that it could be a solution for either of them, not necessarily both. So when I write this, I'm going to take each piece by itself. So if I start here on the left, this says all numbers less than negative 3. So if I was to write that, be x less than negative 3. On the right-hand side, if I'm looking at that portion of the graph, it says x, all numbers greater than 2, so this is x greater than 2. And then I write an or in between. So it is x less than -3 or x greater than 2. If we look at the next statement, we have two inequalities again. This time, however, they are everything in between -2 and 6. So the way I'm going to write it is I'm going to first just kind of see if I can look at it individually. So this says all numbers greater than -2, right? So if I start on the left side, I have all numbers greater than -2. And then if I look at 6, this would be all numbers less than 6, less than or equal to 6. And this time it's equal to because it's a closed circle. So my answer is going to be x is greater than -2 and it's also less than or equal to 6. So with compound inequalities, another nice way of writing that is to say it's all numbers between -2 and 6. Okay, but either answer is an acceptable choice. So let's look more in depth in terms of compound inequalities. Okay, so it says the solution of a compound inequality involving or includes the solutions of one inequality as well as the solutions of the other inequality. Okay, so that means that you can have two inequalities going in opposite directions like we saw in the previous slide, or you could have one inequality describe the solution set for both inequality statements. So either of those is a potential way of looking at an or statement. Normally what will give you the clue in the or statement is that the wording will include an or, like you see here in these two examples. Okay, so if you see the word or at any point in the statement, whether it's written or it's in wording, you got to know that you're doing an or compound inequality. So let's look at the first example. It says -3x plus 2 is greater than -7, or 2 times the quantity of x minus 2 is greater than or equal to 6. So what we're going to do is we're going to solve this for each solution set and then graph it. So I'm going to start with the solution set on the left. So I'm going to first subtract 2 from both sides. So I get -3x is greater than -9. I'm then going to divide both sides by a -3, which remember from 1, 5 means I'm going to flip my sign. So I have x less than 3. Then I'm going to do the work on the right. So first I'm going to do is distribute the 2 to each term. So I get 2x minus 4 is greater than or equal to 6. I'm then going to add 4 to each side. And then I will divide both sides by 2. So my solution set is x less than 3 or x greater than or equal to 5. So when I graph this on my number line, I have 0, 1, 2, 3, 4, and 5. I'm going to put an open circle at 3, and then it's going to be everything less than 3, so that means it's going to be 2, 1, 0, and so on. And then I'm going to put a closed circle at 5, and everything greater than 5, so that's going to be 6, 7, 8, 9, 10, and so on. And so that is my graph. If we look at the next example, this is number 20 from your parts of your homework. Okay, and it says 2x minus 5 is greater than 3, or -4x plus 7 is less than -25. So I'm going to start with the one on the left again. I'm going to add 5 to both sides. I end up with 2x greater than 8. Divide both sides by 2, so I get x greater than 4. Then I'm going to work with the one on the right, and I'm going to subtract 7 from both sides. So I end up with -4x is less than -32. And I'm going to divide both sides by -4. Remember, when I divide by a negative or multiply by a negative, I flip the sign. So this becomes x greater than 8. From here, I have my solution sets, which are x greater than 4 or x greater than 8. So when I graph my number line, I will have 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put an open circle at 4, and it's going to be everything greater than that. And then I'm going to put an open circle at 8 and be everything greater than that as well. Notice we have a small overlap because the first solution set, x greater than 4, would include 8, 9, 10, 11, 12, so on and so forth. So really, my solution set is x greater than 4, and then I just graph this. So I have 0, 1, 2, 3, 4, 5, 6, and so on. And I would put an open circle at 4 and then everything to the right of it. And then that's it. Okay, so this second graph is our correct answer because it includes x greater than 8. Now let's look at compound inequalities that utilize the AND statement. So the solution of a compound inequality involving AND includes only solutions of both inequalities where they coincide. So like we've been doing with the previous examples, they've got to overlap. If there's no overlap in an AND statement, that's not a solution. Okay? So if we look at the first example, it says negative 2 times the quantity of x plus 1 is less than 4, and 4x plus 1 is less than or equal to negative 3. So notice right away, yes, that we have an AND statement right there. Okay, so that's going to be important. So the first thing I'm going to do is I am going to start with the inequality on the left and solve that. So I'm going to distribute the negative 2 to both the x and the 1. So I get negative 2x minus 2 is less than 4. I'm then going to add 2 to both sides. Negative 2x is less than 6. And then I'm going to divide both sides by negative 2. Remember, when I divide or multiply by a negative, I flip the sign. So I really get x greater than negative 3. Okay, so then I'm going to leave that inequality alone. And now I'm going to go up to the top and do the inequality on the right. So I'm going to subtract 1 from both sides. So I get 4x less than or equal to negative 4. Now I'm going to divide both sides by 4. So I get x less than or equal to negative 1. So my two solution sets are x greater than negative 3 and x less than or equal to negative 1. So I'm going to graph my solution. Okay, so we start off with negative 3. It's an open circle at negative 3 and everything greater than it. And then we look at negative 1. It's a closed circle at negative 1 and everything less than it. So to get the graph correctly, I just want the portion where they overlap. So that's right here. Okay, so really, now that I'm going to redraw my graph, now that I can see it a little bit better. I'm going to do all numbers between negative 1 and 3 with a closed circle on negative 1 and an open circle on negative 3. So this is my correct graph, and these are my two solution sets. Now let's look at the next example, which says negative 2 less than 3x plus 1 less than 4. If you see a statement like this one here, then you have an AND compound inequality. Even though it doesn't say the word AND, it's implied in the symbols. So what I do first is I rewrite this as negative 2 less than 3x plus 1 and 3x plus 1 less than 4. So I just break it up, I copy down the 3x plus 1 twice, and I treat it as two separate inequalities. Now that I've done this, I'm going to simplify the inequality on the left by subtracting 1 from both sides, and then dividing both sides by 3. And then I'm going to go to the inequality on the right, and I'm going to subtract 1 from both sides again. And then I'm going to divide both sides by 3. So what I have here is all numbers of x greater than negative 1 and all numbers x less than 1. So again, I'm going to draw my inequality. Okay, and I start at negative 1. It's an open circle and everything greater than negative 1. And then at 1, it it's also an open circle and everything less than 1. So again, if I look at where they overlap, I have an overlap right here from -1 to 1, open circle on each. So what I'm going to do now is redraw my graph. And I'm going to put an open circle at -1, open circle at 1, and then a line between the two. So the second graph is my correct graph, and then these are my two inequalities. Now let's look at some applications of compound inequalities. So the first one, it says in number 26, the value for the area of the triangle is given. Write and solve a compound inequality for the value of x in the figure. So here's my triangle on the right-hand side of the screen. Okay, it's a right triangle. I've got the base of 3 and a height of x. Okay, and then it says that the area is between 9 and 12. So remember, the area of a triangle is A equals 1/2 base times height. In my figure, my base is 3 and my height is x. Right? So really my area is 1/2 3 times x, or 3/2 x if we simplify. So I'm going to substitute this 3/2 x for the a in my compound inequality. So this becomes 9 less than or equal to 3/2 x less than or equal to 12. Now remember in the last slide we talked about how if you see a compound inequality where you have no and statement but it's written with 9 less than or equal to and so on and so forth, this is an and inequality statement. So I'm going to rewrite this as 9 less than or equal to 3/2 x and 3/2 x less than or equal to 12. I'm going to start with the inequality on the left, and right I'm going to solve. So I'm going to multiply both sides by 2. I get 18 less than or equal to 3x. I'm going to divide both sides by 3, so I get x greater than or equal to 6. And then I'm going to go to the statement on the right, and I'm going to again multiply both sides by 2. So I get 3x is less than or equal to 24. I'm going to divide both sides by 3, so I get x less than or equal to 8. So there's my answer. I have the fact that my height has to be greater than 6 and less than or equal to 8. The last problem involves translating a written statement into mathematical symbols. So 28 says a quantity x is either less than 10 or greater than 20. So first thing I notice right away is that I've got the word or. So that tells me I have an or compound inequality. So I'm going to write a nice big or in the middle. And then I'm going to read each individually. So it says x is less than 10. So I'm going to write x less than 10. Then it says x is either less than 10, and it says x is greater than 20. So x is greater than 20. And that is my mathematical statement. And that's the lesson. So the classwork due at the end of class on Thursday, so that's tomorrow, is page 40, numbers 5, 7, 9, and 11, 15 through 29 odd. And don't forget that you need to make sure you're turning in your notes once you complete the video.